Okay, so this is going to be the problem session for 5.5. So this is going to be kind of like a recitation where I just go through a couple problems. My goal is to pick problems that are going to be similar to the ones from the homework, just so you guys have an idea of what to do and you're not stuck. Also for these sessions, you can email me problems if you want. Um, at the beginning of the week, and I will try and do those or similar ones to them. Um, I'm not going to do section 5.4. I took a look at it, and all of them were going to be really annoying problems. Um, by annoying, I just mean they're going to be really long. I don't feel like doing them. So for those, just make sure that you keep like your trig identities in front of you, and it shouldn't be too bad. It's going to be tedious. So I'm going to start with this integral. So we want to evaluate. So we have the integral 9 plus 7x divided by 1 plus x squared. Okay, and because this section is all about u substitution, you might want, or you might, your first thought might be to jump in and try using u is equal to 1x squared, and then seeing where that takes you. And there's going to be a problem here. So I'm going to go ahead and try that and show you what happens with the problem, or what happens there. So to set u equal to 1 plus x squared, then du is 2x dx, and dx is then 1 over 2x du. If I plug that in now, I'm going to get the integral 9 plus 7x over u, and then 1 over 2x du. I will box that off so it's not in the way. So now your goal would try to be to cancel, all these x's here and here, but I can't because this is in the top of um, the integral here, and I have, or the top of the fraction here, and I have parentheses there. This 1 over 2x would have to distribute to both of them, and I would still have a 1 over 2x in front of the 9. So we're gonna have to be smarter than that. So I'm going to erase this. Eventually, this will be our u substitution. So let's get rid of this also. So we'll have to do that again in a second, but we have to be a little clever first. So if something like this happens where like you start trying to do one of these methods and it doesn't work out, you have to turn to a different method. So u substitution didn't work here. So we can't let u equal 9 plus 7x because we're going to run into something similar. I'll be left with that 1 over 1 plus x squared when I do the u substitution. So if all those fails and you have something that looks like this, like it's a rational function, it's a polynomial divided by a polynomial, your next step is to split it up. So this is going to be equal to the integral, and then I just split up the numerator. 9 over 1 plus x squared dx plus the integral 7x over 1 plus x squared dx. And now I have to look at these and try and see if I can do those. And if I can't, then, I'm gonna have to see if I've gone wrong somewhere, copied down the question wrong. Let's see. So this first one, let's pull the 9 out of the integral. I get 1 over 1 plus x squared dx plus, and pull the 7 out here, 7 times the integral x over 1 plus x squared. This first integral, we can actually do without any u substitutions. This is one of those ones that we're supposed to have memorized. The integral of 1 over 1 plus x squared, this is the arctan of x. And now I have this integral, 7 times the integral x over 1 plus x squared. I haven't written down my c yet because I'm going to wait until I do the second integral and put it there at the end. So we're still okay here. So now I need to do this integral. So the integral x over 1 plus x squared. So one of the things you can kind of note is that looks like u substitution is going to work here. Sorry, I dropped the dx both times. So it looks like u substitution might work here. So if you remember what we did before, if u was 1 plus x squared, So I'll go to a new page. So we have 9 arctan x plus 7 times the integral x over 1 plus x squared dx. And eventually you'll be able to do this integral in your head if you stick with this math stuff long enough. So let's try the u substitution again. So u is 1 plus x squared, du is 2x dx, dx is 1 over 2x du. So putting all this together, this is 9 arctan of x plus 7 times the integral. X stays up here, 1 over x squared is now u. Dx is 1 over 2x dx, and we can see here we get what we have happen, what we want to have happen. The x's cancel. This is 9 arctan of x plus 7 times, so pull the 1 over 2 out. So if 7 halves the integral 1 over u, sorry, this dx up here should be a du. So these variables have to match. And now I can do this integral. 9 arctan of x plus 7 halves. Integral of 1 over u is ln of the absolute value of u. And now I go back and plug in terms of x. Oh, sorry, forgot the plus c. Now I go and back and plug it in terms of x, because this is an indefinite integral. 7 halves ln of the absolute value 1 plus x squared plus c. And this can be my final answer. So one thing to note, this thing here is always positive, the 1 plus x squared. So you actually don't need those absolute values. It'll work without them. I think it's okay to leave them in there, but who knows with these computer programs. So that's going to be it for that. So I'm going to move on to the next problem. And this is to evaluate. So I'm only going to do 2 problems for this section because it's a review section. So evaluate the integral x cubed square root of x squared plus 15 dx. Okay, so you're going to look at this and say, okay, if I let u equal x squared plus 15, something weird's going to happen. I'm going to get, so if u is x squared plus 15, du is 2x dx, and I have an x cubed dx here. So that looks like it might not work. But let's try it out and see what happens. So if we let u equal, so x squared plus 15, I definitely don't want to let u equal x cubed because, you know, du would be 3x squared dx, and that does not appear here, so that's not good. So let's see what happens. U is x squared plus 15. Du is 2x dx. Dx is 1 over 2x du, just like last time. And now if I go through and plug in, this is the integral x cubed square root of x squared plus 15. Sorry, x squared plus 15 is now u. So square root of u, and dx is 1 over 2x du. So I can pull the factor of 1/2 out, integral x squared square root of u du. It looks like we might have messed up, but because I've already pointed out that the other u substitution doesn't work, we're gonna have to do something else. And you'll remember, because I only have an x squared here, I can use the relationship between u and x, and I can determine what x squared is in terms of u. So if I solve u equals x squared plus 15 for x, let's do it for x squared, and I get x squared is u minus 15. So plugging that in, so x squared is u minus 15. I'm going to go ahead and write u, or the square root of u, as u to the 1/2 du. This is then 1/2 the integral. So if I distribute this, u to the 3 halves minus 15 u to the 1/2 du. And integrating, I'm going to get u to the 5/2 divided by 5/2 minus 15 u to the 3/2 divided by 3/2 plus a constant of integration. So I'm going through this kind of quickly. Let me make sure that I haven't made any mistakes. No, everything seems okay. So let's go on to the next page. I'm going to do some simplification. I wish these whiteboards were bigger. So we had 5/2 on the bottom, so this can become u or 2/5 out here, u to the 5/2, then minus, I can't remember what that factor in front was, 15. And then 2/3 flips up, u to the 3/2 plus a constant. And now we just simplify. So we get 1/5 here, u to the 5/2. Then I get minus 15 over 3 u to the 3/2. And then we need to plug back plus c. Then we need to plug back in for u. U was, I think, x squared plus 15, but let me double check. Yeah, u was x squared plus 15. Okay, and that takes care of that. Besides the fact that sorry, that shouldn't be 3/2 on the first one. That should be 5/2 on the first one. So this will be our final answer here. And so that takes care of everything there. So I'm going to stop here with this section, review problems. Again, if you have anything you want to see, feel free to email me. I'll make sure to include it in these. So